Hello everyone. Last lesson we spoke about solving physics problems in English. Especially our topic was specific heat capacity. And for now, we're gonna solve the physics problems in English. And let's work on some problems. First of all, how much energy is required to heat 500 grams of water from 20 to 80 degrees? So first of all, I'm gonna write down the given. So the given is mass of the water, which is equal 500 grams. We should convert grams into kilograms. It will be 0.5 kilograms. And the initially temperature 20 degrees of Celsius, and the final temperature, which is equal 80 degrees of Celsius. And we have to find the quantity of heat. And additionally, we know that the specific heat capacity of the water equals specific heat capacity of the water equals 4200 joules per kilograms to Celsius. And we just write down here the solution, and the main formula will be the same as the previous lesson. Q equals Cm T second minus T first, and this is the main formula. So we start with the mathematical calculations. The C is equal 4.0 4200 joules per kilograms to Celsius, multiply 0.5 kilograms and multiply T second, which is equal 80 minus 20, it will be 60 degrees of Celsius. We just canceled the Celsius, the kilograms, and the answer will be in joules. And some mathematical calculations. For 4200 multiply 0.5 multiply 60, which is equal 126,000. We can write as 126 kilojoules. So the answer is 126 kilojoules. The second one. 4,000 joules of heat energy is applied to a 700 gram sample of water initially at 35 degrees of Celsius. What is the final temperature of the sample? So here we need write down again the given. The given is quantity of heat is 4 kilojoules or 4,000 joules. The mass of the sample, which is equal 700 grams or 0.7 kilograms. And initially temperature, which is first temperature, is equals 35 degrees, and we have to find the final temperature, which is the second one. So the solution will be like that. Again, we start with the main formula. Q equals Cm T second minus T first, and from this formula we have to find the final temperature. After that, we have to remove the brackets on one side and the Cm to another side. So this was the first step. The second step is Q divided by Cm, and equals the second temperature minus first temperature. The third step will be the Q divided by Cm plus first temperature, which is equal the second temperature. And the first step, we just write down the operational formula. The second temperature is equal Q divided by Cm plus first temperature. This is our operational formula for this case. So we start with the mathematical calculations. The second temperature is equals 4,000 joules divided by specific capacity of the water, which is equal 4200, multiply to 0.7 kilograms plus 35 degrees. And let's calculate then. We can cancel zeros from this and this one. So it will be 420 multiplies 7, 420 multiplies 7, which is equal to 2.40. The second temperature is equal 4,000 joules divided by 2.40 joules, and we have here the Celsius of degrees, and the kilograms will be cancelled. Plus 35 degrees. So the second temperature is 4,000 divided by 2,940. 4,000 divided by 2,940. The answer will be 136. 136. The kilograms will be, the joules will be cancelled, and we have the 136 degrees of Celsius plus 35 degrees of Celsius. So the answer will be 36.36 degrees of Celsius. So the answer is the second temperature is 35.35 degrees of Celsius. And number 3, the last one, it takes 125.52 joules of energy to heat a 13.2 grams sample of a known metal from 18 degrees to 49 degrees of Celsius. Determine the specific heat capacity of the known metal. So write down the given. The given is quantity of heat, which is equal 125.52 joules. And the mass of the sample is 13.2 grams, which will be transferred into a kilograms, and we can write down just as 13.2 multiplied 10 in minus third kilograms. And first temperature 18 degrees, and the second temperature is 49 degrees of Celsius. So we have to find the specific heat capacity of the known metal. Solution, and the main formula, Q equals Cm, the final temperature minus first temperature. And from this main formula we have to find the C, the specific heat capacity of the known metal. So the specific heat capacity is equal this one divided by this. So Q divided by mass multiply T second minus T first. And this will be our operational formula. And with the mathematical calculations, it will be 125.52 joules divided by mass 13.2 multiply 10 minus 3 kilograms and multiply second temperature 49, first temperature 18, so it will be 31 degrees of Celsius. So the answer will be in joule divided by kilogram to Celsius of degrees. So we just calculate this 13.2 multiply 31. It equals 409.2 multiply 10 minus 3 kilogram divided by Celsius. And the numerator will be 125.52 joules, and the final calculations 125.52 divided by 409.2, and the final answer is 0.3 multiplied 10, and this will be positive. 0.3 multiplied 10 inserts joule per kilograms to Celsius degrees. So this is the final answer. And all three problems are solved. It means that the lesson is over. Your home task will be in the video description. Thank you for the attention. Goodbye, everyone.